It's time to export the knowledge. In this video, we're going to be looking at identifying cubics from their graphs. So here's a graph in front of me here, and I know it's a cubic, and that's all I know. So I want to find the equation for this cubic. So there's a couple of things that I could do. If I knew the x-intercepts, I could try and make a factored form. If I knew that it crossed through the origin, I could do stuff with that, but no, I have the inflection point and I have a y-intercept, so I'm going to put it into inflectional form. I'm going to start with y equals, and I don't know if there's any dilation, so I'm going to put a, x, and I know the inflection point, right, is that to my advantage, cubed plus 1. Now I have this, I need to check to see if it actually goes through that point. So I'm going to sub in x equals 0 and see what happens. Sub x equals 0. I will have negative 8, negative 3 equals negative 8a plus 1. Subtract 1, so now I have minus 4 equals 8a, which means a equals half. And now I can go therefore y equals 1/2 x minus 2 cubed plus 1. I now have more intercepts. I have two x-intercepts, one at negative 2 and one at positive 2, and I also have a y-intercept. Now, this x-intercept must be repeated, so I can use that to my advantage and put it into factored form. So y equals, and I'll start with the repeated one first, x plus 2, it's the opposite, squared, lots of x minus 2. And I don't know if there's a dilation factor or not, so I'll put down a. And I know the y-intercept, so I'll sub x equals 0. So now I'll have 2 squared, which is 4, times negative 2, and I still have my a value at the front, and I know all of this must equal negative 2, so I'm going to be left with negative 8a equaling negative 2, a is therefore equal 1/4 squared, lots of x minus 2. And that's it. Alright, moving on to the next one. I have a little bit more information to deal with now. I've got 3 known points and it looks like it goes through the origin. I'm going to assume that it does. So I don't know any particular intercepts other than the 0, 1. So I'm going to assume that it is factored, right? AX, and I don't know what's meant to be in here. Now, it doesn't look like it has an inflection point. I'm going to assume that it's just some quadratic. So I'm going to put x squared plus bx plus c. Because I have 3 bits of information, I can sub that in. So I know this top coordinate 3 is going to equal 2a lots of squared, which is 4, plus 2b plus c. 3 over 4, use fractions, come on. A lots of, this will be 1 plus b plus c. Expand 3 over 4. A plus ab, ca. And the last one, a 4 minus 2b c. Expand it out, minus 3 as well. 8a plus ab 2ac. So I'm going to do a substitution. I'm just going to make this negative and then sub them together. That way I will isolate the a and b. A 2ac, 8a minus 4ab 2 AC. I will let them equal each other. These will cancel, and I'm left with this. I can divide by 4a on both sides, and I have b equals negative b, and that is only true, and b is 0. So b must equal 0. So from that, have some nice cancelling. This dies, that dies, anything with a b. That dies, that dies. This is dead. This term here is dead. Okay, I'm now going to use this equation with this equation. I'm going to times this equation by 4. 8a 2ac a 4. We can divide by a on both sides, so let's divide by a. Now I have 2c plus 8 equals 4c. I can divide by 2c plus 4 c. I will subtract on both sides, so now I have c equals, really boxing these. Now I just need to solve for a. I'll use this here, solve for it now that I know that c is equal to 2, so if over equals a of plus 2, which is 3, divide by 3, a equals 1/4. Okay, so now that you saw me struggle doing that one question, I'm going to use the CAS to do it instead. So I'm going to open a calculator document. So let's create a document. And now, because we're dealing with the same polynomial quite a bit, rather than typing it out every time, ax, lots of blah, 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 I want to type it out once. There's two ways that I can do that, right? I can just start typing f of x, and then I hit control and then the button next to 9. Right? And you'll get this colon equals thing here. And that will just save whatever you type afterwards as f of x. Now this is the way that I like to do it, but there is another way, and I'll show you that as well. But for now, I just want to enter it. X squared plus b times x plus c. Now, notice how I've put times in. I want to make sure that the CAS knows that bx isn't the variable b is. So I hit enter, and you see that it has done. And now if I hit this little var key above the 9, see that I have f, and I can evaluate it at 2, right? It will give me this funky expression that's not exactly helpful at the moment, but deal with it in a minute. Another way that we could have done it is that, let me just copy this, paste it. I put the function first, and then I hit control and then that variable key above the 9, and I get this arrow. And what this arrow does is it effectively does the exact same thing as this colon equals up here, but it goes the other way. So now I have to do it like this. And that also saves the variable. So it's really a matter of preference. Anyway, we go to menu, algebra, and I want to solve a system of equation. Number of equations is 4, and my variables isn't x and y, it's a, b, and c. So now that I have that, I will just type in my variables. So I know f of 0 equals 0. I know f of 2 equals 3. I know f of -2 -3, and I know f of 1 equals 0.75. And I hit enter, and I get a equals 0.25, which is just a quarter. I get b equals 0 and c equals 2, which is what I proved. So that's it for this video. If you have any questions, feel free to leave a comment down below or contact me on social media, and I will see you in the next video.